Okay, so last lesson, what we have learned is sketching for sine graph. We first learn some formula, and then we talk about how to sketch sine graph. Okay, to sketch sine graph, I have analysis the shape of the sine. In each period, there's 4 stages. Okay, we'll move from the max to min to minimum to min to maximum and keep going this pattern. So the key thing we trying to sketch a sine graph, okay, for main method, I want to find a starting point. This starting point must be a maximum point or a minimum point. It can't be a middle, like on the midline. Because if it's on the midline, I can't predict the next step where the point will be at the maximum or minimum. I don't know. So I want to know a point either from the maximum or from the minimum. Okay, the method we find maximum or minimum for sine is we let the angle in sine to become pi over 2. Okay, if we make that equals to pi over 2, that sine pi over 2 will give you 1. It definitely gives you an extreme value. Okay, 1 or negative 1 is the extreme value. So if sine that equals to 1, then you either have a maximum or a minimum. Then we solve for this t value. Okay, we solve for that. We make the angle equals to pi over 2. We solve for which x or which t can give us pi over 2. And in this case, we solve for that should be pi over 2. And then we have a think whether the value will be a maximum or minimum. It depends on the a value here. Okay, it depends on the a value in front of sine. If that's positive, you will have a maximum value. If that's negative, you will have a minimum value. Okay, that's how we find a point. Therefore, I find this point. A is greater than 0. We have pi on 2, 5. That's our starting point. Okay, on the maximum line. The next thing we think is how long it takes for one step, okay, in the x horizontal distance. So that will be period over 4. That will be period over 4. So in each period, there's 4 stages, and I want to know each stage, okay, each stage, how long it takes. So the period for this question is pi. And how to find period? Period is 2 pi over 2. I find pi. And I want to know the step length. That will be period divided by 4. So it's pi on 4, okay, for each step. And I want to know how to find maximum or minimum or the mean. The mean will be the constant 2 in this case, and I can go up by 3 and go down by 3. So the 3 will be the amplitude, okay, amplitude. So it's how far it can go from the midline, okay, for both directions. That's what we learned last lesson, and we sketched the point until we reach the domain. Okay, the domain is pi on 4 and 5 pi on 4 in this case. Okay, that's sine graph. Let's think about the step first. We label the mean line first, and we see the amplitude, how much go up, how much go down. 3 lines already. Your graph only exists in that 3 lines. And then we can find the period. Period is 2 pi divided by the coefficient in front of x. We have the period. Why we want to know the period? Because we want to know each step how long it takes. So period divided by 4, we find the x step. Okay, it's the distance for the x each step. And then last thing we want to find is a maximum or a minimum point. Okay, to find a maximum or a minimum point, we just need to let the whole angle equals to pi over 2. Because sine pi over 2 give you 1. That's the extreme point. So we solve for the t value when that whole angle equals to pi on 2. And the last thing we think about is the a value, okay, the amplitude. Do I have a positive or negative a value? If it's a positive, we have a max. We can label a point on the graph already. That's a max point. If it's negative number, we can label a minimum. Okay, for that x value, I can label a minimum. And then we just, okay, go for this much step length, and the point will start from max to move to mean. And take another step length, it will go mean to the minimum, and then keep going until you reach the domain. Okay, that's the steps. And now we will think about how to sketch cosine graph. There is only one thing different compared to sine graph and cosine graph. Okay, only one thing different. That is, how do we find the start point? We still need to label the minimum, the mean, the maximum. Okay, we still need to label that 3 things. And we still need to find the period. We still need to find the step length. according to the period. Okay, all the same, exactly the same. Only last point is different, which is I will make the angle instead of pi on 2, we'll make it 0. Why I make it 0? Cosine 0 equals what? 1. Okay, sine pi on 2 equals to 1. Cosine 0 will be 1. So I want extreme point. So I want the angle you insert to be 0. I just want to solve a 0 point, which is quite makes sense why we change pi on 2 to 0. Because we want sine something, cosine something to be 1. Okay, then we solve out the t value and we see the amplitude A. Okay, whether it's a maximum or minimum. No, positive or negative. Positive is the max, less than 0 is the minimum. So all the same, except we only make the value to be 0, the angle to be 0. That's the only difference. So knowing that, let's just sketch a graph here. Okay, this graph will be quite disgusting. Okay, it's a very complex graph. If you can sketch this one, you can sketch any sine cosine graph. Okay, if you can sketch this one, you can sketch any sine cosine graph. Well, if you can vaguely see the grid, I'm not sure if it's very clear on your graph or not. You can count how many boxes are there first. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 boxes. 11, 12. That's 12. Why I label it 12? Because, like, you know, each period is 2 pi. I will tell you why it's 12. I need to calculate something first. Okay, that's a 10. That's a 10. 1, 2, 3, 4, 5, 6. That's a 6. So it's a 26 boxes together on this side. Okay, it's 26 boxes. You don't need to label 26. I just tell you how much it has been divided. And on this side, 1, 2, there are like 2 boxes on the side. So it's 28 in total. Okay. I will find everything out first. Okay, everything out first. What is the mean line? Like, what is the middle? Like, the mean is what? Okay, everyone, like root 3 is the middle. Okay, root 3 is the middle because it's this number add after sine. So I have y equals to root 3. Okay, approximately what's the root 3 equivalent to? 1 point what? 1.7. Okay, 1.732 is approximate value for root 3. So say 1.7. I'll just say better remember some value. Okay, some value. Root 2 is 1.414. Root 3 is 1.73. Root 4 you know. Root 5 is about 2.3 to 2.4. 2.3 to 2.4. That's root 5. Okay, so you have an approximate idea of how large is that. Just not be too vague. Okay, a little bit accurate is fine. 1 decimal is fine. So root 3 is about 1.7. What is the maximum? Everyone needs to think. Okay, that's the amplitude, which is 2. I can go up by 2 units. That's root 3 plus 2. Okay, so what's the approximate value for that? Yes, 3.7. Okay, so 1.7 go up by 2. It's about 3.7. Where is the minimum? I need to go down. I still need the exact value, but I want you to know about where. So it's root 3 minus 2. I need to go down by 2 units. About what? Negative 0.3. Okay, about 0.3. Okay, let's have a think. The maximum value is 3.7 and the minimum is negative 0.3. How we can label that 3 line? It's not given any scales here. You need to find a correct scale by yourself. You don't want to give too ridiculous scale, like extremely small or extremely large. So give a reasonable scale. Well, I would say try to fit as much as you can in this spot, in the graph given. So, okay, about 4. I can say 1, 2, 3, and 4 here, and minus 1 here. Can you see there's a stronger line here? Like, 1, 2, 3, 4. After each 4 boxes, there's a line 1, 2, 3, 4, like that. Well, it's okay. It doesn't really matter. I just say this is the best scale. You need to know how to label a reasonable good x-axis and y-axis. Your graph will look better. Otherwise, your graph can be squished too much or like too high, too low. So I'll use the green color to label those 3 lines. I have root 3. Root 3 is about 1.7. Okay, that's 1.5. 1.75 is here, is a bit below 1.75. It doesn't matter, it's not necessary to be that accurate. So it's about here and go up by 2 units. 3.7. It's about here and go down by 2 units. It's about -0.7. Each small box is 0.25 because 4 boxes is 1. Each box is 0.25. Well, it doesn't matter, not necessarily that accurate, but you should give a reasonably close graph. -0.3 is here. Okay, that's y equals to -2 plus root 3. Here is y equals to root 3, and here is y equals to 2 plus root 3. I can take off the line later. Okay, I can take off the line later. Okay, next thing I want to find period. I want to find period. Can you calculate period for me, please? Calculate period for me. What's the period for this graph? Pi. Okay. Period equals to pi. So it's 2 pi over 2 equals to pi. Okay, what's this step length? What's this step length? Each period, how many steps there will be? 4. So pi on 4 will be the step length. Pi on 4 will be the step length. Period divided by 4. Period divided by 4. Okay, next thing I want to know is a starting point. Okay, it's a starting point. How I can find a starting point? I will make the angle equals to 0. Okay, 2 bracket x minus pound 3. I will make that angle become 0. So x will be pound 3 for sure. Is that a maximum or minimum point? Max, because a is 2. Okay, because a equals to 2 greater than 0, so this is a max point. So the point will be pi on 3, comma, root 3 plus 2. Okay, I almost know everything here. Okay, there's one tricky point. There's one tricky point. Here is what the scale I can have. Like what I should write. Each box, how large is that? Okay, each box, how large is that? Okay, now think about one thing. I want pi on 4, and then each pi on 4 is like each step I will go. I start with pi on 3. What do you think the next step will be? Like the next x value. What's the next x value? Yeah, what's that? Pi on 3 plus pi on 4. What's that? 7 pi on 12. Okay, and you add another one. What's the denominator will be? It's still 12. Okay, it's still 12. Like all your denominator will be something related to 12. It can, maybe some of them can simplify, like 2 pound 3, pound 4, but the denominator overall, most of that will have a denominator 12. So what do you think each box will be a good like length? Pound 12. Exactly, pi on 12, because next one will be 2 pi on 12. Next one will be 3 pi on 12. So this one is a 3 pi on 12. The starting point is actually a 4 pi on 12. Okay, the starting point is actually a 4 pi on 12. So each box will be a pi on 12. So I need to label here as pi because there's 12 boxes. And here is 2 pi. Okay, like it's 26 before. Okay, it's 26 boxes. Okay, 26 like scale. It's about 26. Yep. This one is just make the angle to be 0 because cosine 0 will give you 1. It's an extreme point. You want an extreme point. So the extreme point can only occur when cosine or sine equals to 1 or negative 1. Like it's always like last time you asked me, when make sine is make the angle equals to pi on 2. In cosine, you always make the angle equals to 0. Like that's always. You just need to remember that if you can't really get it. Because it's an extreme point with some reason. So you make that equals to 0. You always give cosine equals to 1 in that point. So that's always at the maximum or minimum. Okay. So I want to start from 4 pi on 12. Okay, where's 4 pi on 12? 1, 2, 3, 4. 4 pi on 12 is here. You just need to count 4 boxes. And intersects with the green line. I know your grid is quite vague and you need to read it quite carefully. But like there will be 26 like small squares, 26 here. So you use 24 until 2 pi. You label 2 pi here and you have 2 more left. You have 2 more left. Okay, the step is 3 pi on 12. You need to go 3 boxes every time, okay, to move to next stage. So 3 boxes to move to next stage. So you count 3. So 1, 2, 3. You will reach the middle here. And go next 3. 1, 2, 3. This one will go to the minimum. 1, 2, 3. Go to mean back. 1, 2, 3. You go to the max. 1, 2, 3. Here. 1, 2, 3. You just keep counting. Okay, the interesting thing is you just keep counting. After you know the scale, after how long it takes you to go, you just need to count. Okay. You should have been like 2 pi on 12 away from 2 pi now. Okay, you should be 2 pi over 12 away because 2 pi is here. You still have 2 more boxes, 2 more scale to go. But you need to go 3 as a step. Which, like, can you have a think? That's very important, everyone. Listen, that's 0 to 2 pi is your domain. Okay, your endpoint not necessarily always exist on the maximum, minimum, or mean line. It can be just in the middle of your graph. Okay, it can be just in the middle of the graph. So when you're trying to sketch, okay, I have reached this point, and 1, 2, 3, the next 3 will go outside than 2 pi. Okay, go outside than 2 pi. You will make the point go outside the period first. I want to see the trend of the graph. So you will go outside for the period. You must go over than the period. So the next point will be 1, 2, 3 to reach the mean line here. Okay, that's what I'm going to have. And don't forget, you only complete the right hand side. To the left of your starting point, you still need to go left. You still need to go left. So from the max, you go 1, 2, 3. You reach the mean, but it's still 1 box away from 0. So you need to keep go for another 3 to the left. Go cover the 0 inside. So 1, 2, 3. You reach the minimum. Okay, how many points you label? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points you have label on the graph. Okay, 10 points you have label on the graph. Well, if you really can't see this quite clear now, go back to watch the video again because it will be very clear on my laptop and you can see all the boxes and how I count them. Okay, so you can watch that again. But now you will have this graph. You will have this graph. I'll use the red color to connect them. Okay, red color to connect them. Pi is not the point. Pi is just the value I have labeled. Okay, I just connect go over than this and same as this side. Okay, same as this side. I just complete a trend first. And can you see I should have endpoint here and endpoint somewhere here. I should have endpoint here because it's 2 pi and 0 is my endpoints. So I'll use my rubber to clear those two parts. Okay, clear those two parts. That will be my complete graph. Okay, that will be my complete graph. And I need to calculate my endpoints. Okay, I need to calculate what is the endpoints. But I will let you to calculate this first. I'll help you to label all the points. Okay, the starting point is here. That's a pi on 3. Well, I will label the in terms of 12. So that is the 4 pi on 12. Max. So maximum is 3 root 3 plus 2. And this one will be like you need to add 3 each time. So that's the 7. Okay, that's the 7 pi on 12 bracket root 3. And that will be 10. That's 10 pi on 12 root 3 minus 2. Here will be 13. 13 pi on 12 root 3. Next one will be 16 pi on 12 root 3 plus 2. And you add another 3. 19 pi on 12 root 3. And you add 3, that's a 22 pi on 12 root 3. Okay, I can't go another 3, it's 25 pi now. So I need to simplify them. So to simplify, that's a pi on 3. That is that's a pi on 3. That is a 5 pi on 6. This one is a 4 pi on 3. And this one is a 11 pi on 6. Okay, you can simplify them. Because I write in terms of in denominator over 12, it will be easy to add. Okay, it will be easy to add. I can just add 3, add 3, add 3 each time. So after that, I can simplify them. Yep. Which one? Yes, this one. Minus 2 here, yes. Minimal. Okay, there's 2 more things I need to do. One is the endpoints. I have 2 endpoints. I need to calculate them. The second is X-Intercepts, but we haven't learned how to solve circular function equations. We'll leave that later to come back to solve for the X-Intercepts. But we need to solve the endpoints first. How do we find endpoints? You sub x equals to 0 and x equals to 2 pi. Okay, so substitute. So the equation is y equals to 2 cosine bracket 2x minus pi on 3 bracket plus root 3. Okay, I will make when x equals to 0. Y equals to 2 cosine, okay, 0 is minus 2 pi over 3 bracket plus root 3. Okay, what's the reference angle for minus 2 pi over 3? Everyone think? Minus 2 pi on 3, where is that first? In which quadrant? Negative is go clockwise. Third quadrant, okay, third quadrant. So here is the angle. Okay, that's negative 2 pi over 3. So the reference angle will be that one. That's pi over 3. Reference angle is pi over 3. So again, tangent quadrant. This is the tangent quadrant. So y equals to 2 minus cosine pi over 3 plus root 3. Okay, question. What's cosine pi over 3? Don't go back. Just think. Half. Okay, cosine pi on 3 is half. That's minus 1 plus root 3. Minus 1 plus root 3. Okay, everyone, just do not always go back to the notes and think about what's the value, because you never remember. The best way is to try to use a method to help you to find out the value. Either set up a table quickly or using the right angle triangle. Okay, then you will remember after like about 10 times, you will remember the value. Okay, so the value is negative 1 plus root 3. I will just put that here. 0 minus 1 plus root 3. There's another one. When x equals to 2 pi. Y equals to 2 cosine. Okay, 2 pi, right? Do not evaluate together first. What I want to do is expand. So that becomes a 4 pi minus 2 pi on 3. And then plus root 3. I will expand the value. It's up 2 pi, that becomes a 4 pi minus 2 pi over 3. That will exactly equivalent to minus 2 pi over 3. I'm not sure if you understand that. This is a 4 pi. You add a 4 pi or subtract the 4 pi, it doesn't matter. The 4 pi is a 2 period. You turn 2 cycle, the angle is still there. The angle is still there. Like the angle is minus 2 pi over 3 plus 4 pi. It will go back to the same position. It's the same angle. Like any angle you add 2 pi, you subtract 2 pi, you do 2 pi times n, it's okay. It'll always give you the same value. So can you see that's exactly the same as before? That's the still minus 1 plus root 3. That is still minus 1 plus root 3. Okay, so I'll label this here. 2 pi minus 1 plus root 3. And if you want, you can take off the straight lines. Okay, the straight line not necessary to stay there. You can take off that. So that will be the correct shape of this graph. Okay, this is the most disgusting graph. Okay, so it's the worst graph you can have. I have go through that with you on the class. Any other graph you sketch this year will be easier than this. So if you know how to sketch that, you should be fine for all the graphs. Oh. Okay, so make sure you can do this by yourself again. Okay, I really want you to do that again by yourself. like, it's not a nice translation. There's a translation pi on 3 here. Okay, there's a translation pi on 3 here. Plus, the step is pi on 4. It's not identical. You know, like the way you shift it is not really same as the step you go through. So you will have a graph like that. You're not finishing at the like maximum, minimum, or the midline point. That's why you need a pi over 12 as each of your scale. Okay, that's why. But other than that, this question is still possible to do. Okay, still following the same method, nothing difficult. The only extra thing you're trying to think about is what is the scale length, like pi on 12 on your x-axis. That's what you need to write. Okay. Okay. Okay, for solutions, I put two exercises together again. So solutions for trigonometry equations, this one is giving you domain. Okay, what's the difference between this one and the next one? Given domain. This one is say, okay, for 0 to pi, how many solutions are there? And the next exercise is the general solutions. If it's general solution, it asks you, I want you to express all your solutions in a formula. Like I want you to give me a general way of expressing your formula. So I'll explain more about that. Don't worry about the title. Just have a look at this graph. I give you a sine graph. Okay, I give you a sine graph. I give you a lot of period from negative 6 pi to 6 pi. I want to solve sine x equals to a half, which is basically as we solve y equals to sine x and then y equals to a half. Okay, I want to solve them simultaneously. I want to solve y equals to sine x and y equals to half. Basically, we're trying to find the intersection between those two graphs. Okay, the intersection between those two graphs. Let's label a half on this graph. Okay, y equals to a half. Half is just here. The maximum value is 1, then the middle is half. Okay, I have sketched a half. You can see the max. The max is 1. The maximum value is 1. The turning point is 1. Okay, then in between the turning point and 0, that's a half. Well, not necessary to be accurate. I just want to see the number of solutions. Can you tell me how many points of intersections are there? No, not on this graph. Like if your graph continues. Infinite. Because your graph can keep going for all the x values. And then a half can keep extending. So there is infinitely many point of intersections. What that means, there's infinite many solutions for this graph, for this equation, without stating anything else. There's infinite many equations. Okay. Okay, now I want you to think about in between the first period from 0 to 2 pi. Can you tell me sine what equals to half? Sine what equals to half? I heard pi on 4, I heard pi on 6, I heard pi on 3, pi on 6. Okay, sine pi on 6 is half. Where's another point? Where's this? What is this point? 5 pi on 6. Because, how do you think about this question? Pi on 6 is here. That's the O quadrant. I can find another value with the same reference angle in the sine quadrant. The sine quadrant is here. Okay, this angle. Here is pi on 6. So the actual angle is 5 pi on 6 in this case. Okay, in the sine quadrant, because it's positive, in the sine quadrant, with the reference angle pi on 6, what's the actual angle? The actual angle is 5 pi on 6. Okay, it's 5 pi on 6. So I have 5 pi on 6 here. Okay, now my question is, what do you think this point will be? the next one, like the next one after 5 pi on 6, the next one, what do you think the next one will be? 2 pi plus pi on 6. And how about this one? Well, don't go minus, go plus way. So it's 5 pi over 6 plus 2 pi. Okay, so from this point to this point, what's the distance? It's a period. Okay, it's 2 pi. So it's next period. Okay, so can you think about this? For a circular function, there is a value. And after a period, you still give the same value because it's turn a full cycle coming back to the same value. So after a cycle, after a period, then the value will be all the same. So you can keep adding period on your first solution and keep adding period on your second solution. So in each period, there will be 2 solutions. Okay, there will be 2 solutions for sine and cosine. And we can keep adding that. So from this to this, okay, from this point to this point, that distance is 2 pi as well. Okay, that distance is 2 pi as well. So basically, I can say, after you know the first 2 values in first period, you can find all the other values by adding its period. Does that make sense? By adding the period, you will get all the other values. Or subtracting the period, you get all the same values. Okay, so that's basically the idea of solving equations. Okay, I'll just repeat that again. You need to find the first 2 values. There will be 2 values for sine and cosine graph. Okay, sine equals to something, there will have 2 solutions. Cosine x equals to something, there will be 2 solutions in the first period. Except minus 1 and 1. Have a think about minus and 1 and 1. In the first period, if you draw a line y equals to 1, how many points of intersection are there? 1. Only this point. Only this point. When you sketch y equals to negative 1, in the first period, how many points of intersection are there? 1 again is this bottom point here. Okay, so you always have 1 point intersection for the extreme values in each period. So the only exception is 1 or negative 1. Sine equals to 1 or sine equals to negative 1. In each period, there's only 1 solution. If you have any other value, you have 2 more solutions. Okay, you have 2 more solutions in each period. Okay, I'll just go one. I'll just go one easy example with you. Okay, one easy example with you. Can you have a look at this value? Can I have a look at this question? Okay, this question. I'll go slowly and please follow. Okay. Shh. The first thing I want to do is I want to know sine bracket equals to what? Okay, don't worry about the constant. You move every constant coefficient to the right hand side. So you will have sine 2x plus pi over 4 equals to 0. There's basically 2 different methods to solve for sine cosine graphs. I'll follow my own method. I know the other one, but I still prefer mine. So I will go through this one, but if you can't get it, you can come here and ask me another way of doing that. But I think it's even complex. So I will try to make you understand this first method. Okay, sine something equals to 0. Can you tell me what's the something? Sine what equals to 0? That's what you're trying to think about. In the first period, in the first 0 to 2 pi. You don't need to think about any other values. You just think about from 0 to 2 pi. Sine what equals to 0? Like the 0 must be the x-axis value. The angle must be on the x-axis or y-axis. You have 2. Remember, you have 2. You have 2 values. Sine 0 will be 1. And sine pi will be another one. So your 2x plus pi over 4 will equals to 0. And it will equals to pi. You can solve out two values. Always remember there's two except 1 or -1. Okay. You need to think about a reverse way. Sine what equals to 0? You should be able to figure out that. And sine what equals to 0 as well. So you find the first one is 0, the next one is pi. Okay, 0 and pi. Okay, that's my step number 1. You can put a note. I want a sine something equals to a constant. And the second thing is think about what can make that equation to be true. Okay, so that's my second step. What angle inside can make this equation true? And the third step is solving for x. Okay, obviously you need to solve for x. Okay, solve for x. 2x equals to minus pi on 4. X equals to minus pi on 8. That's the first for 0. Okay, that's for the 0. That's for 0. And pi minus that is 3 pi on 4. And the next value is 3 pi on 8. Okay, you solve them like at the same time. Or if you feel it's difficult, you can separate the two equations to solve. Okay, 2x plus pi on 4 equals to 0. 2x plus pi on 4 equals to pi. Solve for x. Okay, remember as we talked about in the previous question, I said when you know the first two answers, you know all the other answers because there's a connection between all the solutions. What's the connection? Well, add period, not to pi, it's adding period. Okay, what is the period for this equation? You are adding period on for that. Okay, so what's the period for this equation? Period is 2 pi over 2, which equals to pi. Okay, 2 pi over 2, which equals to pi. Okay, so you have two separate answers. The next thing I want to combine together is called a general solution. Okay, year 12, you need to know that. Okay, they use that a lot. General solution will be expressed in two equations. The first equation will be like x equals to minus pi on 8 plus pi times k, where k belongs to z. The next one will be 3 pi over 8 plus pi times k, where k belongs to z as well. What's the meaning for that? What is k? What k can be? What's that? What's that? What does that mean? Like we learned that in chapter 4 or 5. Like integers. Okay, real is r. Real is r. Z is integer. Means this k can take integer value. Integer value including 0, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, blah, blah, blah. Okay, so all the integer values. So think about why I only take integer values. Because it means I'm adding 1 period, I'm adding 2 period, I'm adding 3 period, I'm subtracting 1 period, subtracting 2 period, and subtracting 3 period from that value. Okay, that is the general solution. This is called the general solution. You just find out the first two values, find the period, and then add the period on that. But the important thing is you must write k belongs to that. You must write k belongs to that. It's part of your general solution. Okay, it's part of your general solution. Why is part of your general solution? Because if k, you not state what is k. K can be √3. K can be 5. K can be 2.5. Again, you can't add half period. You can't add √3 period. You only add the whole period. Yeah, 1 period, 2 period, 3 period. Okay, you subtract 1, subtract 2, subtract 3. You can't subtract half. It's not going to be the correct solution. After I write my general solution out, I'm looking for the specific solution because I have a domain. My x is only in between minus pi to 2 pi. Only in between minus pi to 2 pi. So, what I can do is, I'll put this here. Okay, minus pi on 8. Let's have a think about minus pi on 8. Okay, I can go to the negative side first. If I subtract the period, what that will be? What is it? Negative 9 pi on 8. Is that out of the domain or inside the domain? Out. Negative pi is the domain. Okay, I'm subtracting a period first. From this value, I say this value go to the negative side first. It's out of the domain. I'm not going to continue with it. Okay, it's already out of the domain. I'm not going to continue with it. Okay, I'm adding the period. Okay, after adding pi on that, what that is? Okay, 7 pi on 8 is still within the domain. How about add another one? Okay, 15 pi on 8. Add another one. Okay, if you add another pi, is 23 pi on 8. It's already out. Okay. 15 pi on 8 is very close to 2 pi already. It's about like 16 pi on 8 is 2 pi. So 15 pi on 8. If you add another one, it's outside. So I'll stop here. I'll stop on both sides. So it was three solutions here. But I need to check 3 pi on 8 as well. How about I subtract pi? Negative 5 pi on 8. Is that within the domain? Yes. How about subtract another one? You can't. It's negative 13 pi on 8. It's outside. Okay. Can't have that one. But I can add 3 pi on 8 add pi. What that is? 11. Okay, within the domain, add another one. 19 pi on 8. Is that within the domain? This one's outside. Okay, therefore my solution will be this. Write with the order. Okay, write your solution according to the order. X will be minus 5 pi on 8, minus pi on 8, 3 pi on 8, 7 pi on 8, 11 pi on 8, and 15 pi on 8. Okay, you need to state the answer. You can't just leave your answer like that. Okay, you need to, in the end, give a statement. What is your solutions? So there are 2, 4, 6 solutions. Okay, 6 solutions. That's how we solve for quadratic equations. Okay, I'll give you a homework tonight. Not a lot, but you need to do it. I want you to find the intercept, x-intercept for this question, example 2. Okay, find the x-intercept for this question. There's a lot of space above. You can use the space above. Okay. For this graph, example 2, I want you to find the x-intercept. Everyone needs to practice at least one question. Okay, practice this one. If you have time, finish this 2. Okay, finish these 2. Okay, 2 and 3. If you don't have time, it's okay. I'll go through that on the class. But you must finish the x-intercept. Okay, for example 2. For this one, you must finish the x-intercept to do that one.